Alright everyone, welcome back to Cody's Lab. So today I have a sample of rhodium. You'll see in there, it's nice and shiny, but you also notice there's some bits that are gold colored. That's because this sample is contaminated with gold. This is some electroplating scrap. They were using gold at the same time as rhodium, so it ended up with a lot of gold in it. So my test for today is to figure out how to separate the two. The issue with that is I've never worked with rhodium before, so I vaguely have an idea of what I should do chemically, but I've got like $2,000 worth of metal in this little bottle right here. I kind of want to practice, so I'm going to take a small amount out and basically do it on a small scale, not worried too much about if I lose it because it's be just a small amount. Just to check the chemistry, make sure I know what I'm doing before processing the whole thing. So let's go get some test tubes. Okay, so first we need to get an amount that I'm okay with losing. Let's get like probably about 1/10 of a gram. Just enough that we can know that the process works. I'm going to transfer this into a test tube, just like that. Perfect. And now I need some way to dissolve this. My first thought was to use mercury, because mercury will dissolve gold, but will not dissolve rhodium, which would be very convenient. But this material is in layers of gold and rhodium, so if I dissolve one, and then I hit the other one, the reaction will stop. So I need something that will dissolve both of them at once. For that, I think I'm going to try using zinc. This should dissolve both of the metals. Back out. Just going to drop in a couple of pieces of this zinc here. Let's just do 2 pieces. I'm going to add some borax for flux, so I don't burn the zinc. So I will have to get this kind of hot, because the rhodium mixed with zinc makes something that melts at a fairly high temperature. So let's hit this with a torch, get that all melted together. And hopefully that will dissolve the gold and rhodium into the metal. There's the zinc melted. I'm just going to get this really hot so I can dissolve everything. Okay, that should be good. Set it down in a dish so that the glass breaks, it doesn't go flying. Okay. Here's the zinc. Break the glass off of it. I don't see any undissolved bits, so I think we're good. Nice. Closer look at that. It's a little bit dark on top. I think that might just be oxidation. Maybe some undissolved rhodium. But there it is. I'm going to place this in a beaker. I'm going to add some nitric acid. Nitric acid should dissolve the zinc and any other base metals. Like there could be nickel and silver in this, but those will both be dissolved quite quickly. am doing this in a fume hood. Which is a good idea. Might also be a good idea to just dilute this a little bit. Oh, it's frozen. Help the nitrogen oxide formation. And we got some black powder coming off. That's going to be the golden rhodium, which are undissolved. Essentially what I'm doing here is grinding the metal up really, really fine. Okay, that's all dissolved, or at least the zinc is. That leaves behind a black powder, which I need to separate out now. I'm going to put this into a test tube. Nice. I need another hand. Hang on. There we go. Just wash this down. Okay, let's call that good enough for now. I'm going to go throw this in the centrifuge. Stick that in there. Give it a spin. Okay. Suck out the acid and the zinc nitrate. Now that the zinc and the acid is mostly removed, I'm going to add some water just to wash it. I'll do this a couple of times. Okay, there it is. Acid and zinc has been washed out. I'm going to stick this back in the test tube clamp. I'm going to boil out all the water. Okay, that's good enough. Looks like there's a little bit of residue of zinc in there, so I'll have to remember to wash it a little bit better when I'm doing the full batch. So now I'm going to dissolve out the rhodium and hopefully leave behind the gold. To do that, I'm going to use some potassium persulfate, which when melted will dissolve rhodium metal. I'm just going to get a little bit of this out. Probably fine. Not going to need a whole lot. Just add this to the test tube, and then we'll heat it up with the torch again. Okay. Can we focus right there? Melting point's only about 200 Celsius, so this shouldn't. Just broke the test tube. Okay, no problem. We'll just switch to another test tube. There was a sudden release of heat when the powder mixed with the persulfate, and that caused the glass to break. That's exactly why I'm doing the small scale test. So things like that happen on a small scale. If that would happen on a bigger scale, it might have been a bigger deal. Right now I just have small amounts of loss. I can just put this in a test tube and try again. I think now that it's already combined with it, that release of heat won't happen again. But We're gonna find out. Okay, try this again. Okay, so far so good. Heat the back of it. Okay, I don't need to get it that hot. In fact, the hotter I get it, the more it's going to decompose. So just kind of gently warm it every so often. I'm just going to do this for a few minutes until figure a bunch of it's dissolved. It looks like, I don't know if you can tell, it's a really dark red color. I'm going to try adding some more of the persulfate. I don't think there's enough. So here's another reason why I'm doing this on a small scale. So I can get a better idea of how much of the reactants I'm going to need. So I just doubled the amount. So that's probably over a gram of persulfate. That would indicate I might need upwards of 60 grams for the full batch. Oh, that's not good. Why are you doing that? Tighten that up. I think that's much better. I'm actually going to rock this around a little bit to try to wash some of the stuff down. Oh yeah, it's like blood red. That's encouraging because rhodium is named after its reddish color, the rose color of its compounds. I think rhodus is Greek for rose colored or something. Now that it's cooled off, you can see the color a little bit better. I would call that a muddy orange, actually. But anyway, now I need to dissolve the potassium persulfate rhodium mix. So I'm going to put it into some hot water. There we go. Let that sit there for a while. Hopefully that all dissolves. Okay. Water's nearly boiling. Just going to give this a bit of a stir. Looks like it's dissolving. And that coloring is entering the water. That's a good sign. All the persulfate appears to be dissolved, but there still remains a gray powder. So I think I just didn't dissolve all the rhodium. Well, I'm going to centrifuge this and then transfer the liquid to another test tube. Here we are after the centrifuge. It's definitely an orange color. I'm just going to transfer this into a clean test tube so it can separate out from the powder that's on the bottom. Clearly I'm going to have to run it longer, spend more time in contact with the persulfate to dissolve all the rhodium. Either that or I'm going to need a lot more. I'm leaning towards just needing more time because I didn't really heat it for very long. But since there's enough for color, we should have plenty to test out the rest of the chemistry. So here's some ammonium hydroxide. I'm going to add this to it in an attempt to precipitate rhodium hydroxide. Should be a yellow color. Looks like it's coming down. Let's use my other pipette here to kind of stir it. Might want more headspace in the test tube. I'll just save a little bit of headspace. Add a bunch of the hydroxide. Yeah, there we go. Now it's good enough. Okay, and we'll just run this in the centrifuge. See if we can knock out that precipitate. Okay, still a little bit colored, but we've got some precipitate. Quite a lot, actually. Look at that. Then I'll rinse with the distilled water. Yeah, there's the precipitate washed. There's a little bit of the gray powder that's managed to get through, but remember, we're just testing the chemistry here. And I'm going to add some vinegar to it to redissolve the yellow precipitate. Ah, it's been a while since I opened this. There we go. I don't know how much I'll need. Start with that. Okay, the addition of the vinegar has made most of it dissolve. Now I'm going to be adding some formic acid, just a little bit. This should selectively cause the rhodium to precipitate. So it's producing bubbles of gas. I assume it's carbon dioxide. So it tells me that something is happening. But I'm not seeing any precipitate form yet. So while that's heating up, let's run this again. So this is that gray powder from earlier. I'm going to run it with the potassium persulfate once again, but first I got to get the water out. Sulfate. Let's do this again. Gotta watch. Be interesting to see if it flashes with heat again. Looks like it didn't. Good, at least. Just keeping it melted. Oh, hey. This has changed color. It's more green now. That's a good sign, I think. Okay, I'm done with this. As you can see, it's cooled off and it's orange again. This has turned black. I think that's a good sign. I'm just going to let it continue heating. I'm going to add some water to this to try to dissolve out the sulfate and rhodium again. I'm just going to stick this in there with it so it can be warm. Hey, look at this. There's a black powder forming in there. If I'm not mistaken, that should be rhodium black. Basically, very pure rhodium powder. Nice. So the one is dissolving again, as you can see. Look at that. It's settled out. I believe that's pure rhodium. So this one, the persulfate has fully dissolved. Let's get a close look at that and see what this looks like now. Zoom in. Zoom. There we go. That's a little better. What we got in here? Okay, there's still some gray powder, but it looks like gold to me. So I did. I've concentrated the gold. So that means it worked. I separated the gold from the rhodium. Obviously, I think I can do this better if I heated it for longer, and etc. But I've confirmed that the chemistry works. Hope you enjoyed. I'll see you next time.